In calculus, you'll actually spend a lot of time dealing with exponents that are in fractional form or rational exponents. So it's going to be nice to take a little time just to review some of these facts associated with them and look at just some various properties that come up. Okay, so first thing is just understanding what the fractional exponent means. So we're just going to look at some properties and then just translate that into some numerical sense. So let's say I've got this first one. Square root's a normal one, but we're going to go with cubed root. We're going to go cubed root of 4. Well, cubed root of 4 is equivalent to or translates into 4 to the 1/3 power, meaning whatever this root is matches the denominator. Okay. Well, what if you've got something that's got an exponent inside the square root? So, a radical, sorry. So let's say we've got the cubed root of 4 squared. Okay, that would translate into 4 to the 2/3 power. And again, the 3 is the denominator, and the squared bit, that's the numerator. Okay. And then we've got similar rules about distributing the exponent in. So say we've got the cubed root of 4x squared, and I would like to rewrite that in its separate form. So that would translate to 4 to the 1/3 times x to the 2/3. And then we have this, and this is albeit a little bit rare case that could come up, but if you ever see it, it'd be nice to know how to translate that. So what if I've got the cubed root of the square root of x? What would that literally translate into? Well, that would be the cubed root of x to the 1/2 power, because square root translates to 1/2, and then this would translate to x to the 1/2 to the 1/3, or x to the 1/6. So you literally can, if that ever does come up, you can literally just multiply the two exponents together. And then the last sort of property review would be the quotient case. So let's say I've got the cubed root of 4 over x. We can literally just split that up into a fraction. So that would be 4 to the 1/3 over x to the 1/3. Okay? And so now we're just going to go in and practice all of these different properties and just make sure we have a decent understanding as to what it does with numbers and with parentheses and that sort of thing. In this first example, we're going to look at where is the exponent attached. So is that 1/2 attached to the 16 at all, or is it just the x? And the parentheses just have it attached to the x. So we're going to bring the 16 down, and then we're going to do the exponent to an exponent rule. So we're going to take the 4 times the half, which gives us 16x squared. Is that one. Now compare that to number 2, and in number 2, this time the 16 is attached to the 1/2 because of the parentheses. So we're going to essentially bring the exponent over to the 16, and then x to the 4th times the half again. An exponent of 1/2 simply means square root of, so this would be square root of 16, which is 4. And then we already know x to the 4th to the 1/2 of that's just 4x squared. Okay. Number 3, again, the 27 is attached to the exponent, so we can distribute that out, 27 to the negative 2/3. And then this would be x to the 3 times negative 2/3. Now, they both have negative exponents, so to make them positive, we're going to translate them into the denominator. And let's see, 3 times negative 2/3 is just x to the negative 2, so that makes that x squared. Okay, so let's talk about 27 to the 2/3. One of our rules allows us to either square it first or cube root it first. And 27 to the 1/3 power is something we should know how to do. So let me put that all over 1 here. We still have this as an exponent, or in the denominator of a fraction. So 1 over 27 to the 1/3. And then we're going to square that, and we still have times x squared. And bring it over here. All right, well, 27 to the 1/3, that's just cubed root of 27. That's 3. And then 3 squared would be 9. So our final answer is 1 over 9x squared. And all of that's in the denominator. Okay, number 4, 16 to the 3/4 times x squared. So 2 times the 3/4. Let's see, so we're going to do 16 1/4 is something easy we can handle. That's just the 4th root of 16. And that's just 2, and then 2 cubed. And then this would be x to the 3/2. So we got 2 times 3/4. And this translates into 8 x to the 3/2. And we're just going to leave it in the exponent form, so we're fine. Number 5, we've got a negative exponent. So initially the first thing we can do, or about the only thing it looks like we can do, is bring that to the denominator. But since we've already talked about factoring, we should stop and look and see if there's something else going on here. And if we do that, hopefully we recognize, this 4x squared minus 12x plus 9, that factors into 2x minus 3 squared, and then we're taking that to the 1/2 power. So this, the 2 and the 1/2, that multiplies to give you 1. So this is really 1 over 2x minus 3. So there was a clever factoring hidden in that exponent problem. Okay, number 6, we've got x plus 4 to the 1/2 in the numerator and x plus 4 to the negative 1/2 in the denominator. Well, we've got a negative exponent in the denominator, so to make that exponent positive, we're going to bring it up to the numerator. So x plus 4 to the 1/2, and then times x plus 4 to the 1/2. Now, oddly enough, these two things are the same term. So if you multiply two of the same term, you're going to add the exponent. So this is really x to the 1, x plus 4 to the 1/2 plus 1/2, because we're adding those two 1/2s together, and that just gives us x plus 4. Okay, number 7, we're going to distribute in the exponent first. So the exponent to the term rule. So that'll give us 8 to the negative 4/3 times, rewrite that a little bit clearer, 8 to the negative 4/3 times x squared, and then the 2 is times negative 4/3. Okay, well, how do we get rid of the negative? We bring that down to a denominator. So now we're looking at 1 over 8 to the 4/3 times 1 over x to the 8/3. It's a positive exponent. All right, let's talk about 8 to the 4/3. That's cubed root raised to the 4th power. Well, let's see, 8 to the 1/3, cubed root of 8, we're going to raise that to the 4th. Well, cubed root is just 2 to the 4th, and 2 to the 4th is 16. So all of this in number 7 simplifies down to 1 over 16 x raised to the 8/3 power. Okay, number 8. We're going to bring the exponent over to each number, so negative 32 to the negative 3/5 times x to the negative 5, and then it's negative 5 times negative 3/5. Now the x part, let's talk about that for a second. You get a negative and a negative. That means it's positive. So this piece is going to simplify down to just x to the third. Now, with the other number, the 32, being raised to the negative power, we're going to bring that to the denominator, which will then make it positive. And the negative part just sticks with it. So negative, and I'm going to take advantage of the fact that I can raise that to the fifth power, and then I'll come back and emphasize this negative here for a second. Raise that to the fifth, to the fifth root, and then I want to cube that. And then I'm going to bring the negative out front. The negative actually is not attached to the exponent itself. The negative is hanging out in front of the 32. So I can simplify the 32 first, and then when I get done with the 32, then I just put a negative out front. Negatives are nice in that sense that I can move it and a fraction up to the numerator, denominator out in the middle. But okay, so what is the fifth root of 32? So what number times itself 5 times gives us 32, and hopefully that's, you figured out that's 2. So we're really looking at 2 cubed. So this works out to be negative. We got x cubed in the numerator, and we have 2 cubed, or 8, in the denominator. So it simplifies down to that. All right, in number 9, we got a whole bunch of different interesting things going on here. There's a lot of different ways we could start this. I'm noticing I've got a bunch of negative numbers and a bunch of positive numbers. I'm going to take advantage of the fact that I can split up, just in the numerator, for example, I can split up the 3, the x, and the y, and take those all to the negative 1/2 power. So that would be 3 to the negative 1 times the negative 1/2. And then I've got x squared times a negative 1/2. And then I've got y to the negative 3 times a negative 1/2. And this is all over 6 to the negative 2 times, the exponent is times, not the, well, the coefficient is times, but negative 2 times negative 3/2. Then it's times x cubed times negative 3/2 times y to the negative 2 times negative 3/2. We're going to multiply out the exponents there and see what kind of numbers we get. So for the 3, we get 3 negative 1 times negative 1/2 is a positive 1/2. The x, we end up with x to the negative 1. And y, we get 3/2. In the denominator, we get 6 cubed, 3 is positive there, x to the negative 9/2, and y to the positive third power. Okay, so then we're going to go term by term and kind of see where they should end up at. The 3 and the 6, oddly enough, don't divide. You've got the cubed root of, the square root of 3, and you've got 6 to the third power. 6 to the third, I believe, is 218. Those aren't going to divide out, so you're stuck with a cubed root, square root of 3 in the numerator. With the x's, so let me kind of keep track of this here. You've got 3 to the 1/2 and 218 so far in the denominator. With the x's, we have a negative 1 and a negative 9/2. Which one's bigger? Because they both could flip-flop and switch places. We just want to have x's show up in one location, though. And 9/2 is bigger, so if I bring it up, it'll be a positive 9/2. So that's going to become x to the 9/2 minus 1. And we'll come back and simplify that. And then y, I've got 3/2 in the numerator and 3 in the denominator. And again, the question is, where is it bigger? And 3 is bigger than 3/2. So y 3 minus the 3/2. And then I've got some fractions that I need to simplify out. And I'm just going to give myself a little more space here. Okay, so our final answer is going to be, let's see if I can get a straighter fraction bar here. Our final answer is going to be 3 to the 1 halves and 218 in the denominator. Sorry, 216. Go back and fix all this. Sorry for those that are, that's not right. It's supposed to be 216. It is 216. Alright, so we got 9 halves minus 1, which is 7 halves. And we have 3 minus 3 halves. So that'd be 3 halves, oddly enough. Y to the 3 halves. Let's circle that. Okay, number 10. Got a lot of things going on here. I think, let's see. I'm going to say, let's try to do some reducing here before I deal with the square. Because I see I've got 10 over 15, and I can reduce that down. I can divide 5 out of both of those. So that'd be a 2 and a 3, 2/3. And I see x squared over x cubed, so that's an x in the denominator. And I see y to the 1 half in the numerator and y to the negative 1 half. And if I bring those up to the numerator, so they're both positive exponents, it's 1 half plus 1 half, which gives me y. And then the same logic with z. If I bring z up from the denominator, it being negative, I get 3/4 plus 1/4, which is just z to the first. And that saves a lot of calculations. So now I've got 2 squared, which is 4, y squared z squared, over 3 squared, which is 9, x squared. So that one little step saved a lot of effort on our part. Okay. Number 11, we're going to, let's see. Let's distribute out the exponent first. Let's try that rule and see if we can simplify this down a little bit. So I got 8 to the 1/3 power, try that again, x to the 2/3 power, and y to the negative 2/3 power. And then I'm going to multiply that by 27 to the negative 1/3. X, let's see, 3 times negative 1/3 is negative 1. And y would be negative times a negative is a positive, so that would be y to the first. Okay. All right. Let's see, one more round of simplifying where we can. Let's see, 8 to the 1/3, that's the cubed root of 8, so that's really just 2. And then I see x to the 2/3 and x to the negative first. So if I add variables, if I add exponents on the variables, that's 2/3 minus 1, so that's negative 1/3. And then we got y's. Again, add the exponents there, so negative 2/3 plus 1 would give us positive 1/3. And then so 27 to the negative 1/3, well, cubed root of 27 is 3, so that gives us 3 to the negative 1. And then I can just rearrange this in terms of a fraction. So I get 2y to the 1/3 in the numerator, and I get 3x to the 1/3 in the denominator. All right, and last but not least, number 12 here. I'm going to rewrite, I'm going to bring up x to the, let me do that. I'm going to bring up x to the first, x minus 1 to the negative 1 half. I'm going to bring that up out of the denominator to a positive. So that'll make it x minus 1 times x minus 1 to the 1/2 power, since that'll make that a positive. Oddly enough, I'm multiplying two things that are the same, so I'm going to add their exponents. Well, what's the exponent of x minus 1? The numerator, that's just x minus 1 to the first. So I went 1 plus a half. So this will simplify down to x minus 1 to the 3/2 power. So that's not that bad.